the topic of my presentation, TRIZ and DFP, it is very natural to underline that connection. As you know, TRIZ includes problem statement tools, analytical tools, problem-solving tools, and concepts of association that we usually set. As for problem-solving tools, design for patentability is totally relying on TRIZ, because the idea behind design of patentability, it's also finding new... Hello? Can you hear me? Hello?
Yes, doctor, we can hear you. We can hear you.
Because one of major parts of design patentability is identifying new problems that on solving basically preserve the major approach of the competitive patent, but at the same time obtaining freedom to operate. That is why majority of new development, majority of new things in design for patentability, it's about different new rules and approaches in analysis. When it comes to problem-solving tools, it is using TRIZ problem-solving tools. That's why it is absolutely natural that in the beginning, the approach had different names. For example, TRIZ for IP strategies, TRIZ for circumvention. That's how it was presented, and that's how it has been existing on the market for quite a while. But then, you know, when consulting with different IP professionals, they pointed out that actually the name does not reflect the real, the core competence of the method, because by IP strategies, usually in IP world, they understand drafting strategies, licensing strategies, filing strategies, things like that. At the same time, what design for patentability offers, it is actually the design steps. You know, it is not what is usually considered patent strategies. So that kind of pushed us to think how to change the name. And besides, along the development, it became clearer that there are some specifics of using analytical and problem-solving tools as well in such a way that the solution that we obtain has better chances to satisfy criteria of patentability. So that's how the history of this DFP started. The very first presentation on that, at least that's one, I presented it to TRIZ community. It was at one of TRIZ congresses long ago. It was 1991 in Petrozavodsk. So that's, I found a picture of that. You can see, you know, Henry Suller, that was already kind of in not very good health. And what I like the most, you see very young myself, you know, on the left-hand side in those glasses. Okay. Hello? Okay. So that's when I obtained my LLM.
Yeah. I'm not able to mute that guy. I don't know who it is.
Some tapasya.
Tapasya ma'am, if you can hear, please keep your microphone on mode.
I am not able to. I have also expelled her.
Okay.
You
All
can
right.
continue, doctor.
Yeah. At that time, I got my LLM, master degree in patent law, and it became much clearer for me that TRIZ tools can be used for multiple aspects within IP domain. So since then, because it has passed quite a lot of years, since then, this TRIZ for patent strategy, or what I call now design for patentability, it gained more and more popularity. Actually, it attracted first a lot of attention from IP professionals. As of now, there are a number of patent offices that have actually training on that methodology for themselves, for their experts, for their examiners, as well as providing services to customers. Last year and this year, there were multiple workshops for Swiss Patent Office of Poland, South Korean Patent Office, Chinese Patent Office. Um, Especially, I'm proud of doing this training for it in Swiss Institute of Intellectual Property, because Einstein worked there. And another thing that pushed up development of that methodology is cooperation with World Intellectual Property Associations. You probably heard about that World Intellectual Property Organization. It is a specialized agency of the United Nations that is running a lot of activities in the area of promoting it, maintaining databases, and such. But it is an agency. It is not an educational institution. That is why conducting different courses at the same time, they cannot grant degrees in that domain. So they selected a number of universities all over the world that they are funding. And those universities created departments, schools, centers where they teach different aspects of intellectual property and offer master degrees in international patent law, so-called LLM. And the major goal of those programs, master degree programs, as they call it, is IP for design. That is why when they heard about design for patentability, it was accepted by them like the other side of the bridge. IP for design is basically educating engineering professionals to protect the solutions generated in innovation projects to the best of their ability, while design for patentability offers some design steps. It's a design technology so that in the end we actually achieve the project's goal, but at the same time the solutions automatically or almost automatically satisfy criteria of patentability. That's why they perceived it as two sides of the same bridge. That is why WIPO, a number of universities funded by WIPO, they included design for patentability into their master degree programs in international patent law that they are funding. That also created quite a boost, for the methodology for deployment and also for development, because a number of people joined in efforts, to develop new things that would enhance the goal, the probability to achieve goal of design for patentability. That's how number of other things were added to the methodology in addition to TRIZ, I repeat, problem-solving tools when we need them within DFP. It is primarily TRIZ. So as I already mentioned, there are a number of applications where we use TRIZ within DFP. Within DFP. The very first and probably, so first of all, I want to specify that there are kind of two branches within DFP. One branch, it is just running innovation projects, pretty much like other innovation design technologies, including TRIZ or modern TRIZ, or, it has different names, systematic innovation, gen TRIZ, pragmatic innovation, and other names. But the usage of tools is such, the recommendations of using tools or different strategies within those tools are such that in the end, with a very high probability, we have a patentable solution. And there is the second branch, I call it IP-centered projects. It is specifically about existing IP or IP. That includes walking around competitive patents. It includes strengthening your own IP. It includes developing patent firewalls. It includes identifying white spots for patenting, and so on. There are other details and nuances, that IP-centered projects might have. For example, revitalizing the expired patents or revitalizing the patent application that has been abandoned, and things like this. Often, those objectives can be achieved by engineering means, not only by legal means. So today I would like to just introduce probably the most often used application of IP-centered projects, just the innovation projects where, we use different analytical problem-solving tools. There is a set of recommendations, which tools and what kind of variants of these tools to use to have higher degree of probability to get a patentable solution. But within this webinar, I will focus on IP-centered projects. And the very first one is competitive patent circumvention. That is probably the most known application of DFP, because that was a major part of TRIZ for patent strategies. For those who know TRIZ, there is a very interesting tool in TRIZ, if you remember, that is called trimming. By trimming, we understand removing a component that is responsible for the issue. But prior to that, we perform function analysis, identifying all the useful functions this component performs. And when we remove it, we redistribute these useful functions among remaining components of the system and supersystem. That's what is called trimming. And actually, to perform trimming, we use this combination of tools. First of all, function analysis, just because we need to know what functions every component within our system performs. And the trimming itself, the process of eliminating the problematic component and redistributing its useful functions among remaining components. So it was pretty obvious, and it was actually used and presented many times, that that might be an interesting and probably the most straightforward track of patent circumvention, because so we have a claim, independent claim, the components that are listed there, are in front of us. How these components operate within the context of the patent, it can be easily obtained from the description of the patent. So basically, we can decompose the claim into components, identify functions these components perform, basing on the description of the patent. And after that, we perform trimming technique, basically throwing out some components from the independent claim and enabling the remaining components of the in the claim or in the supersystem to perform these functions. Once we did that, it created a number of engineering problems that needs to be solved, problems about enabling those new carriers of the functions to perform them because they had never been designed to perform the functions we have just delegated to them. And after that, we use TRIZ problem-solving tools to solve those problems created by trimming. And as the result, we have a new architecture of our system. Basically, the same set of functions performed by a different set of components. We have fewer components, or maybe we added another component from a supersystem. So the approach is pretty straightforward and has been presented to TRIZ and engineering community, quite some time ago. But if we look how often it is used and what are the results of this kind of application, we might be disappointed because not that many people were successful using this. So that was one of the things that attracted my attention. Why? Because this concept of patent circumvention using function analysis and trimming is extremely clear. It turned out that it is not that simple because patent claims in different patents are drafted in multiple different ways. Just an example, there are many more kinds of claims that you can come across, but just several examples. There are claims, I call them component-based claims. So basically the claim includes number of components that shows, to what assembly that or another claim belongs, and that's it. If the claim is drafted this way, yes, then function analysis and trimming would work fine. But very often the claims are drafted differently. There is a strategy to draft a claim using few very basic components. Those you cannot trim because that is fundamental of the device, designed for that purpose. And all the tricky things, all the new things, they are described by the functions these components perform among themselves. And this functionality is a part of the claim. In that case, just trimming these very few basic components, it's impossible because you need to trim half of the system. You can actually do it, but it will be total redesign. And in patent domain, circumventing competitive patent it usually implies, some change but of the device, but still preserving, the major approaches there, the principle of operation, the general design structure. So total redesign is not considered competitive patent circumvention. It's just considered an alternative. That is why, if all the criteria of patentability of the competitive patent are based on the functionality of the listed components, basically trimming does not work here. The major approach is reshuffling the functions, rearranging the functions, redistributing the same set of functions differently among the same components. Also, another situation, there is a strategy drafting the claims, including just major basic components, and trimming would not work there because we need to trim again half of the system. If there are 3 components and you need to trim at least one, it's 30% of the system. But all the criteria of patentability are based on attributes, location, in what direction components move, time at which they get activated and operate. So again, in that case, our patent circumvention activities should be based on what is called attribute analysis. Attribute analysis, attributes, that's what I meant. It is, location, time, direction. And for patent circumvention using attributes, we need to change those attributes with some beneficial purpose. But usually when we do it, we'll lose advantages of the attributes that are described in the competitive patent. Leads us to what is usually called attribute contradiction. that is immediately linked with TRIZ problem solving tools, because we have tools for resolving physical contradictions, for example, in time, space, direction, and so on. So a number of techniques based on circumventing competitive patents using attributes. So depending on how the claim of the competitive patent is drafted, you select the circumvention strategy. It is not like one strategy fits all. Yeah? So we need to keep in mind that. So that's where the differences start from usual approach that we had before, or from or for kind of traditional rules how to perform function analysis in TRIZ or beyond TRIZ. Because if you remember, because many people studied TRIZ and function analysis and know the rules that are required to be observed during component analysis, interaction analysis, function modeling, we know that it should be, the components should have a rest mass, and usually when we were teaching TRIZ with Alex Lubomirsky, I'm sure maybe he's here, maybe many know him. You remember a hole, as an example, a hole cannot be a component because really it is not a component, it is a specific shape of other components that make an orifice or a passage or something. With the competitive patent circumvention rules, actually hole is a component, because if we manage to design or change the architecture of our device, eliminating the hole, and it is beneficial, it can be a hook for obtaining freedom to operate, and so on. So a number of those recommendations and rules that are different from traditional rules of function analysis is growing exponentially, because as more people started using the method, and they contribute a lot with those additional recommendations. Another thing, I will show that in the cases that I prepared. Another thing, there are so-called, I call them ghost components. These are components that are present in the claim, in the independent claim of competitive patents, but not explicitly. When we actually dismantle the claim and write out the components mentioned there, you cannot find that component, but there are multiple ways how this component can be implied. And I remember one of the projects that during training program at Hyundai Motors, and the claim said there are two chambers hydraulically isolated from each other. So the team was writing out the components and the great chambers, and that's it. But what does it mean, hydraulically isolated? It implies that there is a wall there, but the wall is not listed explicitly, neither in the description nor in the competitive claim. But we need to identify those ghost components that increases our chances of competitive patent circumvention, right? Another thing that I wanted to show you, and there is an example, it is patents that we want to circumvent. Again, I many years ago I gave them a name, dragon patents. Why dragon patents? Well, it is kind of relates to a Russian story or fairy tale. You probably heard many of them about the situation when there is a city where people lived peacefully, and at some moment a nest of dragons settled nearby and started terrorizing the population of the city. Because in Russian and European kind of folklore, dragons are usually nasty. They are bad guys. That's why, for example, in China and some other Eastern countries, they told me, no, you need to change the name. This is a bad name. because in China, for example, dragons are
Hello.
good guys.
Dr.
Hello?
Sergei,
Yeah.
are you moving the slides? Because I think the slides have got frozen.
No. Yeah, no.
You're not even moving them?
I'm not moving. I'm just telling
Okay.
the story,
I
and then
thought
I
so.
will go through
I
this.
thought
Yeah.
so. Yes. Okay.
Thank you. Yeah. So, so in Chinese folklore, dragons are good. But again, this term is based on European and Russian approach to dragons. So from time to time, heroes showed up trying to liberate the people of the city, but obviously they failed because they disappeared, but the dragon continued living there and terrorizing people. So a new hero showed up, promised to liberate the people, went to the place, to the mountains where the dragon lived, and found the dragon and killed him in the battle very, very easily. So he was surprised himself. But before running back to the city and informing his fellow citizens about the victory, he felt a little bit tired, so he decided to sleep for a while. So he woke up refreshed and started running to the city. But when he was running, he noticed he could not run very fast as he used to. He looked around and he saw there was a long dragon tail behind him. He turned into a new dragon. Why I called those complex patents dragon patents? Because if these patents have in their claim something, for example, a component that is named in a very generic way, for example, general way, for example, means of support, means of transportation, means of heating. In that case, when you trim this component and delegate these functions to another component within the claim, that new carrier, new component becomes means of support. It becomes means of heating. It becomes means of whatever. So for dragon patents, for patents where the components are described in that very general way, means of support, receiving mechanism, opening station, there is the whole list of those dragon words, and you trim it and delegate these functions of this trimmed component to other components become those means of support, opening stations, and so on. So looks like trimming cannot be used there, because once you delegate these functions to something else, the dragon is reborn like phoenix. That's why usual trimming will not work there. So there are a number of those specific cases, and devil is in detail. That's why, yes, in general, one of the major tracks of patent circumvention is trimming, but when you start really using it, it does not work without the plethora of those very specific recommendations depending on different structure of the claim, because it requires different tricks and different approaches. That's what is the difference between the kind of traditional TRIZ for IP strategies approach that we had before and DFP. So I want to show there's several things about it within a couple of cases that I prepared. So a usual patent circumvention, it is just component-based claims. That's where just use trimming. Besides trimming, by the way, there are other ways to walk around competitive patent. There is another big track that they call substitution. Instead of trimming components, we substitute it with another component based on a different technology and such. But this substitution approach is fraught with its own dangers, because within many patent laws, there are lurking other difficulties known with the names of doctrinal equivalence, prosecution history estoppel, and number of other wrapper estoppel, and a number of others. So when we do substitution, we should keep that in mind. if we have to choose between these two approaches, trimming and substitution, I gravitate towards trimming and its variants, and the substitution, it is just in case we need to generate more ideas or less preferred, because those who do not have probably IP education or have not been exposed to IP legal things, they do not know that during the infringement cases, I attended several of those in Boston. The patent judges usually conduct the infringement lawsuit in two phases. The very first phase, it is called element by element comparison check. So when the patent, every component of the claim is compared with a corresponding component of the device, for example, that is allegedly infringing the patent. And when we use trimming, basically we always have a component that is missing, to a component in our device. To a component in the competitive patent, there is no component corresponding component in our device because we trimmed it. That's why it kind of disappeared. So most likely the lawsuit will stop at that phase. But if we substitute, in that case, for a component of the competitive claim, there is a component responsible for that in the device. That is why the lawsuit goes to the second phase, and then they start comparing every couple of components to identify if they're equivalent or not. That is why the trimming approach, with all its modifications through attributes, component trimming, or virtual trimming, or whatever, there's reshuffling, redistributing the functions, that is a little bit akin to partial trimming. If you remember, partial trimming is basically really not trimming the component, but just redistributing some of its functions and still preserving that component, keeping it for performing the functions that this component can easily perform. And when we remove some function from that component, became small and light and does not cause any problems. That's why function redistribution, it is kind of akin to partial trimming. So all the actions redesigning the claim using trimming approaches, they bring new problems for solving. Attribute handling gives us attribute contradictions that we need to resolve. Trimming, removing components for component-based claims, it also will give us trimming problems to solve. Redistributing functions, the same. And that's why when it comes to problem solving, as already mentioned, that's where DFP is totally basing on TRIZ, function-oriented search and the tools of classical TRIZ. So just one example, one case study from level 3 training programs from Hyundai Motor Company. At Hyundai Motor Company, there is they run TRIZ programs level 1, 2, 3 for 12 years already in a row, practically without any gap. There was 1 year of gap, but actually it is an annual process, not event, because it's multiple events. There are multiple levels. And usually level 3, when people bring really serious projects to this program, more than 50% of those projects are patent circumvention projects, because Hyundai Motors has a very interesting strategy, among others. Of course, they do very extensive R&D themselves. In their global R&D, Hyundai Kia Center in Namyan, there are like almost 5,000 scientists. One of their approaches is to identify strategically important and commercially profitable patents of competitors and circumvent them. There are a number of experts that are trained to do that. So that was one of the projects of that program. So maybe some of you know about variable compression ratio engine. Right now it is all the modern cars are equipped with that. Because usual engines, okay, they work on high compression ratio because actually that is better usage of energy. It's better to work on high compression ratio. It's better uses of energy. We have, better, clean burn. Basically, we burn all the fuel, but there is considerable load, on the walls of the engine, and because the temperature in the chamber increases very fast, that can they can lead to explosions. The probably most advanced variable compression ratio, so usually it is from 1 to 10, it is air-fuel ratio, but variable compression ratio, it's a 14 to 1, 1 to 14, whatever. And probably the most advanced variable compression ratio engine that is used in cars right now, it is engine from Nissan. Infinity cars are equipped with that. You can see that the side actually stress impact of the variable compression ratio is much lower than in the usual standard piston engine. So Hyundai Motors, for a number of years, they licensed this patent, variable compression ratio engine patent from Nissan. And when they started educating their people in DFP, that patent immediately kind of emerged, because why to pay licensing fees? That's not a very cheap thing. And one of the projects that level 3 team brought to training was to walk around that Nissan patent on variable compression ratio, as they call it, VCR engine. And the approach was classical trimming. So we take the independent flame, literally with a pencil underline components that I mentioned there. And these are components of our model, and then describe the functions. Functions actually are amazingly simple. It's about holding and moving, nothing else. And they were pretty aggressive. With one stroke, they decided to trim 5 components, and they did that. And if you see, it is necessary to move the lower link. So if they trim the whole bunch of components, someone needs to do that. And they delegated the function to move lower link to the cylinder block, basically to the wall. You can see they even presented that trimming problem as, kind of substance field models, because they try different TRIZ problem solving tools. And in the long run, they came up with a solution. You can see they equipped the block with a slot, through which the pin is sliding. So the design on the left, that is in Nissan, they substituted with the design on the right, that is Hyundai Motor design. The first simulation, showed very good results, so they started preparing a patent application for that. Just for your information, Hyundai patents only strategic things and things that go to production. They do not patent just average ideas for the sake of patenting. Just to mention, to add to this fact, Hyundai Kia Global R&D Center usually gets funding for 1,000 patents to file 1,000 patents a year. It is for 4,000 people, scientists and engineers. TRIZ program on the average yields 100 patents a year. So basically those 30 people or 25 people that graduate from level 3 program, they generate 10% of all IP, that the thousands of engineers were supposed to generate. It is just to note the efficiency of TRIZ and DFP methods. But when they started preparing this patent application continuing the experimentation, something came to their mind. What if someone takes their new idea, applies the approach, and circumvents their approach? That belongs actually to methods of IP strengthening, because who needs weak patents? So that's why it makes perfect sense to actually try and circumvent your own patent application, your own idea at the stage of filing, because not filing, but applying, because it will allow you to understand the gaps of your newly generated idea and then close those gaps, changing the design or with dependent claims or with some other things. There are separate tools for strengthening your IP. I already mentioned, I will not talk about them during this presentation, but there are plenty. So here, trying to circumvent your own idea, that was kind of a step of strengthening your IP. So they took the function model of their new idea and tried to trim something else from there, and they managed to trim another control pin, that is critical there. And they came up with another embodiment, with another design without that control pin. So the whole process was like that, starting from the left to right. Nissan patent, their idea number 1, and their idea number 2. They patented both idea 1 and idea 2, but they continued experimentation, prototyping. And it turned out that idea number 1 was better than idea number 2. Idea number 2 had a number of secondary problems. That's why their decision was, to choose idea number 1. And they continued digging in, different types of packaging, the vertical package, the horizontal package. And ultimately, they picked up the horizontal package of idea number 1. And they proceeded with that. So it's pretty close, or maybe it is on the market already, because Honda is very aggressive with this stuff. But their back is covered. Other variants that are feasible, but maybe more difficult because they require solving secondary problems. So it's not immediate. They are not immediately available, but their back is covered. For some reason, the movie is not working, but believe me, it is wonderful. There is this yellow cam that changes and switches from low compression ratio mode to high compression mode operation. Then a couple of examples with those tricks, the ghost components. That is something that was done, when I worked with Gen3. This is our patent application together with Alex Lubomirsky. It is published. That is why it is in public domain. It's electronic cigarette. In the premium market of electronic cigarettes, Philip Morris was number 1. And the second in rank, in their domain, British American Tobacco is trying to catch up with Philip Morris. And one of the projects was about walking around one of major patents on electronic cigarettes of Philip Morris. If you look at the claim, of this patent, basically it says there is an apparatus for evaporating volatile components from a smokable material that can be tobacco, marijuana, and whatever, pretty generic. And what it includes a heater, elongated heater along the length of the cigarette. And the heater consists of plurality of independently controllable heating regions. So there are many heating regions, and these heating regions, they heat one after another. First heating region heats, evaporates volatile components from the smokable, that part of smokable material that is adjacent to that. Then it is turned off, and then the second heating region starts, the third one, the fourth one, and these heating regions are turning on and off along the length of the cigarette. So gradually, all the volatile component is evaporated from that portion of tobacco. So if you look at it, actually, that's a very difficult claim because it includes just one component that, or several components, these heating regions, that's it. And all other things, it is tobacco, or smokable material, and the component that we volatilize. So actually, there is nothing to work with. Yeah, just what to trim, because there are not that many components. But if we do decomposition, in a smart way, trying to find those ghost components. That's why identification of ghost components, it's very important. Some of them are revealed through attributes. Some of them attribute analysis does not catch. So there are some other ways to extract, to distill those ghost components. Pay attention, independently controllable heating regions. It means there is a controller, that controls these heating regions. However, the controller is not explicitly described in the claim. So the function model here, even with this controller that we found hidden, still the function model is not that big. So not many things to work with, just heating regions and the controller. All other things are basically kind of super system. By the way, another rule, when we build component model for patent circumvention, forget about system components, super system components, all that thing is not needed because the components that I mentioned in the claim, that's with what we work. We can add other components for describing how the whole device is working, but those are not valid for the purpose of trimming. So basically this function ranking, there's a splitting components of system, super system, all those ranks, basic, additional, auxiliary, all those functions, all that is not needed there, for DFP. But some other things are needed, that's also where the difference between a TRIZ application of tools within TRIZ and application of same tools within DFP is. So pretty aggressive trimming, heating regions were trimmed and only one is left, controller was trimmed. So the direction was the following, just to make one heating region and the hotspot is moving along that heating region on itself, automatically, by itself, something like we have in the candle. Once you start the candle, after that, it does not require any control. The candle melts the wax and the everything happens automatically. So now it was necessary to find a technology, how to do that. And here function-oriented search, would be very handy because problem-solving tools come from TRIZ. I told you, DFP uses them. And an interesting technology was found. It is not that it's kind of something new. It's pretty old technology called electric candle, developed by a Russian engineer, Yablachkov. The idea was used long ago in the last century, actually, 2 centuries ago, for lighting the streets of cities, St. Petersburg and so on. So these are 2 carbon electrodes with insulator in between. You apply voltage and it ionizes air, generating an arc. Arc has, it's very bright, it generates light. That's why it was used as a lighting device. But at the same time, it generates very high temperature. That is why carbon electrodes are burning. The insulation in between, usually it was plaster of Paris, also is burned. And this device really is burning similar to candle, absolutely self-controlled. And there is only one region through which the hotspot is moving from one point to another. So that's the technology. But function-oriented search does not take the technology directly. The technology, it gives just the principle of operation, but the technology needs to be adapted. We need to solve adaptation problems. But this technology triggered a number of ideas. One idea, to have the electrodes, they're made of metal. Of course, there is no arc or disposable electrodes. They're made of metal, and the insulation layer is paper. The tip, one end of this paper is carbonized. Basically, it's conductive. So you apply voltage, and actually the electrical current is running through the electrode and through this carbonized tip of the paper. The temperature there when it passes through the layer of paper, because of the high resistance, is the highest. So the paper continues carbonization process. So the circuit becomes shorter and shorter. The hotspot is traveling along the length of the electrodes. So basically the circuit becomes shorter and shorter and shorter and shorter. So we have an effect similar to this Yablachkov's to electric candle, where the isolation layer of paper is burning while the hotspot is traveling along the same heating element. Just because the length of the electrical circuit changes. Another concept, shape memory alloy. Of course, how can we live without the shape memory? One electrode is regular, the second is made of shape memory. Of course, the joint between these two materials has the highest resistance. This is the hottest spot. The temperature there makes the shape memory material cling to the regular electrode. So again, the length of the circuit decreases, and the hotspot continues traveling along the length of the electrode. So the heat is traveling along the length of this heating region, like a candle. A cheaper version using bimetals, very similar thing. And another idea to use shrinkable films. You put these electrodes into shrinkable films. The joint point, again, it is the point of the highest temperature. The film shrinks and pushes these two electrodes together, and it shortens the electrical circuit while the hot spot keeps on traveling along this one self-controlled heating region. I put in that example because here we have this ghost component. And the Dragon patent, that's also from Hyundai Motors, that is relatively recent, last year, a year before, something like this. But again, it's already patented. That's why I'm free to talk about that. That's about safety system. You probably think that the most dangerous place in the car, seat in the car, is next to the driver. It was many years ago. Right now, the driver and the front seat passenger, they are protected with about 12 airbags, including outside airbags. So Hyundai cars are very well equipped. The most dangerous seats right now, it is back seats, because in case of side crash, one passenger kind of slams into the other, and the other is spread around the wall of the car. So at Hyundai, they were thinking about developing something to protect backseat passengers, and they thought about the airbag, that would separate the backseat passengers in addition to the belts. But the patent search showed that Honda patented this idea, and very broadly. So according to the Honda patent, there is an airbag deployed between the two passengers, and that airbag is deployed with the means of support. In the description of the patent, there is a specific embodiment. There is like a wall that springs up inside that airbag, but the claim, independent claim, states means of support. Well, the team listened to all this trimming thing, and started using trimming. So they decided to trim that means of support, delegate this function to the roof of the car. So when the airbag deploys, it just had hooked to that lock on the roof of the car. But their patent team said, no, that's infringement. Hyundai Motor patent team, they are tigers. 80% of them are former examiners of South Korean Patent Office. That's why it's much easier to go through Patent Office than through Hyundai Patent Team, internal, that scarecrow of all the engineers. So they say, no, that would be an infringement, because here we have this dragon, that means of support. You delegate this function to something else, and it does not work. Something else becomes that means of support. So there are several ways how to deal with this situation. One of them is to use trimming rule B. Basically, you work with the airbag itself without changing anything else. So what they did, they came up with an idea. The airbag, it's like a mushroom. It gets deployed, separating the people, and the walls of the car, serve as supporting components, for the airbag. But, they're walls of the car. So there is nothing, no means of support that we introduced. The patent team actually passed it, that would be patented, but the simulation showed that it would not work. First of all, too long to deploy. That's quite a big airbag. And besides, it takes too much space in the car for storage. So they had to go back and redo, and that's what happened. In South Korea, engineers, especially at Hyundai Motors, the corporate culture is extremely aggressive in the good sense. They continue working until they get something. So the final idea that was patented, and actually maybe it's already, maybe not, it's 2 years ago, but maybe it's close to commercialization. So basically the airbag is smaller, and it has such a shape that it fits between the headrests. So the supporting things are headrests, but still they are patenting the shape of the airbag on deployment. Yeah. So that is this dragon thing. I wanted to show something, real. All right. So this is an article when this TRIZ and Dfp were deploying wide in Korea. That's one of the central newspapers there. There's a section, Hello CEO, about this TRIZ tools and Dfp use, because it's not only Hyundai Motors. Samsung has also a long history of that. There are people who are focusing on that application. All right. And another glimpse, not only patent circumvention, but for example, identifying white spots. There are different tools, there are technology maps, there are tools that are not based on TRIZ, but as we talk about TRIZ and Dfp, one of the tools that can be used, it is this S-curve analysis. Circuit breakers. That actually appeared as the result of our big programs for Siemens that we did together with Alex sometime long ago. Commercial circuit breakers, the parameter, several MPVs that the market actually values the most: sensitivity, accuracy, and controllability. So what was done? So they built function models, not function models, S-curve. They performed S-curve analysis for different MPV and different types of circuit breakers. For example, sensitivity of the main circuit to the actuation effect. There are mechanical, electromechanical, electromagnetic, and light actuation. And S-curve analysis shows that the first three, they are at the third stage of the S-curve. Basically, all major things have been already patented there. Does not make splitting hair. And you see how many providers there are on the market. While light actuation is still in the middle of the second stage of the S-curve. There is some space left. Some important improvements can be made, within the same S-curve. The accuracy, again, we have thermal, we have magnetic, we have electronic, and you see the electronic, the solid state devices for increasing accuracy. They are in the middle of the S-curve. Actually, when it was done, within Gen 3, we were doing that. Actually, it was lower. It was in the beginning S-curve. Now it is more developed, so it's probably middle of the S-curve, but still it makes sense, to find, to look for white spots right there. And as for level of controllability, there are two options: just to cut off the the current, cut off the circuit, in case of the increase of the current, or a smart one, basically to cut off the excessive current without actually stopping the device. So definitely that is a more promising operation right now. S-curve analysis is only one of the tools to identify white spots. There are some other tools. Usually, that DFP offers, usually this is done with sophisticated patent research, looking at patents and analyzing just the patents that had been filed, the applications and the patents that exist. However, the articles say that it is not very accurate because there are strategies when competitors, just to actually distract the competition, they patent aggressively in one direction, kind of pretending that it is very promising, while it is not really the right direction. So it is just a red herring, just to confuse the competitors. That's why if we just start analyzing the patents filed, the applications filed, if we start analyzing patents, we should be careful that we can be victims of that distraction. That's why, those methods have their disadvantages, but different types of technology tables of those who attended my workshops some time ago, I talked about one variant of those Alexandrov matrices. Basically, that's a goal of the patent and the method the goal was achieved. Looking at that matrix, identifying where a certain goal has never been achieved by a specific approach, that also will reveal white spots. So as for white spots, there are TRIZ-based tools and there are other tools there. But from TRIZ, we use S-curves. Now, in industry, this DFP, right now, it's basically an explosion, especially, for example, China. In China, it is very special because in China, if you remember, 20 years ago, the quality of products was not that good. That's why companies were not interested patenting in China. I mean, European and American companies, it was not perceived as a market. That's why Chinese companies just took inventions of others, those that had not been patented in China, and utilized them in China and consumed them in China. It was not a crime, it was absolutely legal because there was no IP protection for those engineering solutions and products in China. But during the last 20 years, the quality of Chinese products became pretty good. And the products are cheap, the labor is cheap. That's why these products are pretty competitive in European and American market. But China cannot bring those products to these attractive markets because on those markets, the IP that had been used in Chinese product is still valid. That is why many companies in China are ready to pay any money to walk around those patents that they had embedded into their products, and now they are still valid, and there would be an infringement if they start exporting the products to those attractive markets. So in China, in general, IP, it is almost like a national policy. The increased number of patents filed, they're number one in the world. Now they're focusing on quality of those patents. That is why in many universities, they created courses, and many companies are actually focused on that. That is why, but for universities, it is very attractive, not only in China. I managed to push this DFP course at MIT. Now, Boston University is also opening it. Purdue University, Purdue is a pretty good school. They already have a course on design for patentability. They just, enriching them with this TRIZ-based and not TRIZ-based, all these non-traditional things. Tongji University, as I already mentioned, we have this WIPO program since 2018. So it is going on, happened this year online, but still it happened. And that's where basically patent executive, patent engineers from all over the world come. There we have like heads of patent offices of countries that are there. Of course, they do not perform this project themselves, but they find the methodology attractive and they are eager to educate their examiners and their patent engineers in that domain. This is in China. Yeah. So that's a glimpse, on this DFP, and also, just explaining how different it is from TRIZ. Just to kind of underline it in the end that definitely the connection is very close. When it comes to problem solving, it's totally TRIZ. As for analytics, and that's what is specific for design for patentability, there's different processes to formulate these problems, new problems, solving which will give me patent circumvention or IP strengthening ideas. That is different from TRIZ. Yeah. All right. Oh yeah, of course, because once we started working with MIT, we started working with WIPO. So they suggested, because the number, the body that needs to be trained, in which engineers need to be trained, is growing. Of course, if there are problem-solving tools of TRIZ, problem-solving tools, they needed to be taught there. And of course, all the specifics of the analytical tool also. So that is why, in cooperation with WIPO and European Union, because European Union invested some money in development of DFP, so they require that their brand is there. So we introduced the certification on that. All right. So I think I talked a little bit more than I planned, but still, I'm within the time frame. If you have some immediate questions, I will be happy to reply.
Thank you, Dr. Sergei, for this insightful presentation. And I have already started to get some questions. I'll just read it out for you. In case of very ideal innovation, why should we register patents and stop others from making which can help the society? Yeah, you understood the question.
Yeah, I understand. Well, again, who we? You say we. Who is that we? Because
we would be the individuals, probably.
Yeah, because that we is very different. Part of the we are people who invented, or companies who invested money and invented that. So they incurred some expenses, right? So they own that IP. They spend some intellectual energy and effort. And the other part of we are other people. That is why these we are very different. The very idea behind the Patent Institute, I mean, not educational institution, but the patent patenting, it is to get some commercial compensation for the efforts the company or inventor incurred. If everything belongs to everyone from the beginning, there is no incentive, for companies to do this innovation. They need to be rewarded for that. And the whole Patent Institute, it is based on rewarding the inventors. They are getting exclusive rights to use the result of their inventing. After 20 years, it belongs to everyone because they think that 20 years, it's enough time, to compensate. And also it is not just compensating because the patent owners, they pay fees every year for maintaining, the patent, and that fee is growing. So, after 5th or 6th year, that fee is quite substantial. That's why many companies actually abandon patents because it commercially doesn't make sense. That is why it is not that patents are just exclusively belong to someone and others cannot. If you look at dynamics, the patents are maintained in force for just several years. Only very kind of general or patents that have big markets for them, they are maintained for 20 years. Yeah. So that is not a technical questions. That are questions that society needs to address. And I think it is not ready yet to give the property, because it is property, it's intellectual property, just to give someone's property to everyone.
Perfect, Dr. Sergei. How TRIZ concepts help in setting claims for patents?
Claims? How to draft claims better? Well, to tell the truth, that's another area that has not been explored much. I think that there may be something, but the major check, the major help from TRIZ for drafting a claim, it is this check, trying to circumvent your own patent application, playing devil's advocate and trying to circumvent. And if you find multiple solutions for circumventing your application, then it is pretty obvious how to change the claim to close those gaps. By the way, that's another type of kind of TRIZ projects, and within Jan TRIZ, we had that when one company wanted to acquire another company that owned a very important technologies. So it was easier to acquire that company than to buy licenses for these technologies. But of course, that company understood their value and they asked for a lot of money. And TRIZ project was actually to find patent circumventing ideas, not because that buying company, the buyer wanted actually to get into this business, but to use these patent circumvented ideas as bargaining chips during the negotiations for the acquisition. And when it was done and the company that was going to be acquired looked that there are so many alternative ways that could potentially circumvent their IP, they immediately dropped the acquisition cost. So that's why answering this question, to tell the truth, it has not been explored. The best way, I will try to circumvent the claim the way you have in mind, and it will immediately reveal the gaps. That would be the best way.
Thank you, Dr. Sergei. Can TRIZ help in any international disputes on patents for any matter? It's again.
Well, again, you see, TRIZ is not in legal. TRIZ, Dfp. They are not playing in legal domain. They are playing in technical domain. That's how it is different from the advice that the patent agents and patent attorneys can provide. TRIZ and Design for Patentability, it gives a technical advice. Of course, it is the best when it works in combination. And again, different patent laws in different countries, they have different nuances. For example, when we're talking about the substitution, when I substituted one component in the patent with another component, in the United States, UK, Japan, there is an interesting doctrine there in the patent law that is called prosecution history estoppel. It means that if during the prosecution, if during the correspondence with the patent office, the applicant, when I apply for a patent and I correspond with the patent office, it's called prosecution history. If during this history, the patent examiner claimed that my patent is too general, it is not patentable, and I need to narrow down the claim, and I agreed, the claim was narrowed, and the patent passed, the patent was granted. In that case, I lose my right to use doctrine of equivalence. That's why I cannot actually expand the interpretation of my claim broad enough. My claim protects only what is written there literally. Having in mind in countries that have prosecution history estoppel, it's much easier to circumvent the patent using substitution approach. So that's why, that's where the most powerful things are at the boundary between two disciplines, TRIZ and IP, and that's what Design for Patentability is. It's a merger with some TRIZ things adapted for kind of drafting or patent circumvention or patent strengthening and legal things from different patent laws.
Thank you, Dr. Sergei. is it possible to implement TRIZ and Deaffit techniques in a non-product or service industry?
Well, again, I don't know why they talk about service industry or business thing as something different. Right now, many countries, they have IP protection of business models. That is why whatever we're talking about TRIZ for business, many things there can be actually patented. That is why I'm impatiently wait for some really solid evidence that there are patents, in business. And so what is service? Service, in a way, you can always look at a service as a technological process. Yeah, there is no machines, there is no raw material and something, but it's a procedure. That is why, we can improve the process that is of emergency room in the hospital. We can improve the process in some other domain, and that will be service. That's why, to my mind, it can be used in those areas.
Okay. Thank you, Dr. Sergei. Can reverse engineering combined with TRIZ called as design for patentability?
Say it again, the beginning.
Can reverse engineering combined with TRIZ be called as design for patentability?
Well, it is not really reverse engineering. You see, if we just do patent circumvention, right, and we do trimming, right, basically, and we say that the new solution can be patented, right? So it means it is not just reverse engineering. From legal perspective, it's a totally independent, patented, separately engineering solution, right? But I agree that reverse engineering, could be used for, for the same purpose, right? If I did reverse engineering, it will help me to circumvent competitive patent. That is right. Yeah.
Okay.
Okay. So that's why friends of mine, who are I have several, those are patent lawyers. I mean, really hardcore lawyers. They're litigators. They go to patent court, to several times a week. And they keep on telling me, when we talk about patent circumvention, that it's not patent circumvention. You create a new patent because from the point of view of the patent law, it's a totally new engineering solution. But from engineering perspective, we have the same set of functions performed by fewer components. That's why for us, it's kind of same solution, but so we circumvented the patent.
Thank you, Doctor. If an inventor replaces two components in an invention with another component, which does the work of both, can it be considered trimming, and is it patentable?
So if I have two components and I substituted it with another couple of components,
and which work, yes, and another invention with another component, which does the work of both.
It depends. You see, that's another thing I totally forgot. Thank you for this question. One of the major directions, or at least big direction of entrepreneurship, small and medium companies, it is hybridization, because it's very easy for entrepreneur to take one thing and the second thing, combine them and have a product that performs both functions, right? But you see, very often it cannot be patented. When we talk about criteria of patentability, there is the first criteria, novelty, that should be worldwide new. And the second criteria, this is usefulness, feasibility. And the third criterion, and that is the most difficult to my mind, it is inventive step or non-obviousness, that we call it in the United States. Let me give you an example. I usually use that example because it's very simple. Laptop that you carry with you all the time. It is not very light, heavy, so I don't like to carry heavy things. So I had a bright idea to equip this laptop with wings. So as I walk, laptop is flying after me. I don't need to carry it. And I decided to patent it. Now, the novelty criterion. Have you ever seen laptops with wings? Probably not, but you should not be so sure, because actually I checked. there are laptops with wings in animation cartoons and movies, and it is enough to jeopardize as to compromise the novelty criterion. But it is not doesn't matter. Supposedly, no one heard about a laptop with wings. But then when the patent examiners start checking this non-obviousness or inventive steps, what will they do? They cut off the wing separately and laptop separately. And they will ask me, laptop, is it using the same thing usual laptops do or something special? Usual. And the wings, do they do what usually wings do? Yes, they move things. So the patent examiner will tell me, so what did you invent? What is the inventive step? You took one known thing, joined it with the second known thing, and you have a summation result. It is not patentable. So I need to have a synergetic result that I cannot see in either of these parents. I get it only when I combine them together. For example, I will tell patent examiner, you did not pay attention. Look, I attach the wings in such a place, in such a way that when they move the laptop, they cool the chip. That's why a laptop works better. So I have that synergetic effect I don't have in laptop separately, I don't have in wing separately, only when combining them together. That is the key for satisfying this inventive step or non-obviousness criteria. That's why if I took two known things that are used in before and they perform known functions, I just stuck them together like pencil and eraser. So it is not patentable. The patent examiner will kick it out. But if I look at the eraser and I think, what functions can it perform? What properties does it have that I can use? Oh, the eraser is soft. It's convenient to hold it in, instead of a solid pen. So what if I make the eraser slidable? So it's sliding, it can slide. And when I use the pencil, I just hold where the eraser is. It's softer for my fingers. But when I want to use the eraser for erasing, I move it back to the tip and I use it for erasing. Or that is something new. So basically one of the ways to create a patentable hybrid, I call it innovative hybridization. It's basically doing function modeling of one parent, function modeling of another parent, and see how functions of one parent can be used for improving the second and vice versa, to do this cross-linking. Not that, there are some other things like identifying features, properties, and then converting them into functions, something akin to super effect analysis or inverse function oriented search. So that application, innovative hybridization, again, it has some specifics, that's what DFP kind of contributed. But when it comes to specific tools, we borrow them from TRIZ. That's why it depends, answering your question. It depends. Just to say that if you just combine two things, substitute one thing with another, it can be equivalent. It can be infringement, or it can be not patentable solution. Basically, you do not infringe anything, but you cannot patent it.
Okay, thank you, Doctor. So the next question is, the topology optimization of an existing component can be patented.
Yes, it can be patented. Again, there are its own tricks, because, for example, the same company, British American Tobacco, just infusing different herbal flavors into tobacco pieces, because you smoke, you want to have mint flavor, you want to have hazelnut flavor, I don't know, different. The infusion process is very long. They kind of drive steam enriched with herbal flavors through pieces of tobacco. So actually, it is patented already. That's why I can talk about it. That also was a result of our, together with Alex, British American Tobacco program. So they had an idea, apply using standard inventive solutions. And the second field, double subfield, use ultrasound. So use vibration. So the idea was when you drive steam through this bed of tobacco, don't do it continuously, but just an impulse. It's like, poof, poof, poof. So the tobacco pieces started jumping. So they levitate in the steam. So the contact area is washed by steam better. So infusion is better. And then they thought about resonance, doing resonance frequency. So the amplitude is higher, tobacco pieces jump higher, so the infusion is better. But these things are known. You cannot patent that. But they did research and they identified the optimal range of frequencies that are the best, that give the best results specifically for tobacco product, for tobacco industries. And this optimization, right, kind of optimization patent, that is patentable because it is the result of their specific individual research. They identified the most optimal range of frequencies for that technology. And though the technology is known in general, but this almost optimal range of parameters, it can be patented. That's what Alshula called not patentable inventions, but actually it is patentable. We should be careful though, because if the patent on just ultrasonic technology is valid, it will be infringement. That's why we need to to do it smartly, so we would not infringe the more generic patent, but it is patentable.
Thank you, Doctor. Can you please throw some light on patentability in the field of education?
Field of education. Again, what can be patented? Device, method, a microorganism, now business model, and IT thing. So just in general, like a method of education, I don't know, it cannot be patented. It is not an object of, again, I have a master's degree in patent law, but I'm not, I did not take a bar exam, so I cannot be a patent lawyer. But again, from what I know, to the best of my knowledge, the educational methods, as education methods, you cannot patent this. But if you present it as a method, as a process of, okay, educating, whatever, yes, probably you can patent it as a technology, as a process, as a method. I know that there are several people who are very interested in that. They are predominantly professors. They are working in that area, but I have not seen any kind of clear results. But in China, in Jilin University, there's a professor who is very, very absorbed into kind of using TRIZ for improving the educational methods. Yeah. So as a method, as a technology, as a process, probably, we can think about using TRIZ for that. But again, there are a lot of kind of interpretation and adaptation work needs to be done because, moving from technological process to this non-technical area, like in any case, at every time when we move to non-traditional field, IT or business, the terminology changes and interpretation changes, and sometimes it causes changes of the tools themselves.
Okay, thank you, Doctor. How is the evolution of a system solution assessed in a S-curve? Is it only commercial data or anything else?
When we build S-curve, you mean? When
yes.
we do research, right? Yeah, of course, the big data, but of course, not only commercial one, but every time when we do innovation benchmarking, it's not only commercial data. That's where TRIZ is different from others. So we can use patents, we can use research articles, these things, because in regular marketing procedure, the articles, patents, that kind of information is not taken into consideration. Marketing tables must include only commercially available products. When we use it in TRIZ, the innovation benchmarking includes all that all that data. Mm-hmm.
Okay.
So not only what is commercially available, but yeah.
Okay. Can we patent engineering solutions that come up with the help of machine learning or artificial intelligence? And if so, whose intellectual property will it be considered?
Yeah, that's not a very new question, by the way. You know, in his early days, Altshuler created a very simple machine. There were just inventive principles, right? So that according to what he told us at his workshops, that machine basically recommended inventive principle. So it was like a matrix, basically. And he used the principle, sometimes the inventive principles recommended by the matrix, you do not even need to brainstorm. You have an impression that it gives you direct solution, like turn the object upside down. Okay, you turned it upside down and it worked. Gravity did all the things and it worked. And then Altshuler wrote a letter to the patent office of the Soviet Union. Okay, who is the inventor? Because the machine invented that, not me. And the patent office was totally confused. They said, no, the machine cannot invent. And according to Altshuler's story, they corresponded for a long time. Of course, he was teasing them. But the question is not new, right? So, and to my knowledge, this question has not been answered. Because, artificial intelligence, machine learning, it's on the rise. And these situations, can surface. Definitely the patent will be given to the inventor, but inventor of what? What part of that machine learning in the artificial intelligence, what part, what is the contribution of the inventor? Yeah. So no, it is. I don't have a direct answer to that.
Right. Okay. If we use problem solution approach instead of an embodiment based approach in patent claim drafting, is trimming technique still an effective one?
So I need clarification. So when we one is the second one, I understand. What is the very first drafting?
If we use problem solution approach instead of an embodiment based approach in patent claim drafting, is trimming technique still effective?
Yeah, I understood. So I need clarification. What do we mean problem solution approach?
Yeah, problem solution approach. Even I didn't get the question. Problem solution approach.
Because I understand the embodiments that where I specify components and everything. That's what is usually done. What is problem solution approach?
Professor, a means plus function type of an approach.
So again, it means what function? Well, again, you see, I think I understood the question. So if we just do this, you see, again, according to the definition, the idea, we cannot patent an idea. We can patent an embodiment. That is the basis of the patent law. That is why just to describe functions and in a very generic way, it will lead us to the response from the patent or from the examiner that the solution is not patentable. Okay, so that is why to have this function approach, in a very general way, it is not enough. For example, I want to patent a method of changing the electrical bulb. And the method includes obtaining a new bulb, approaching the closest wall, walking on the wall, then walking on the ceiling, and then substituting the bulb. If I submit such an application, of course they will kick it out, because the question will be, how will you walk on the wall? How will you walk on the ceiling? So there will be a lot of unanswered questions, and I will have to specify all these things. That is why, if we talk about function approach, again, we need to see how general that description is or how specific it is. Probably with a certain level of specificity, we can, but then we can patent it, but we will bump again into the dragon situation. If we just describe the function, then what can we do? We need to delegate these functions to something else if we use trimming. Usually, if we have, and by the way, there are patents that try to do that, and they passed, right? So in that case, there is a way maybe to try and circumvent it, or it also is used in building firewalls, applying cause-effect chain analysis. Basically, to go to do the chain to understand why I need that function, because very often there are several layers, of functions that are needed in the patent. For example, a polymerization process that includes mixing and heating, and then you do cause effect. Why do you need mixing? Why do you need heating? Something like cause effect chain analysis, and you need heating to bring energy to break polymer molecules. Okay, now can I introduce energy only by heating? Probably not. I can use UV radiation. It will not be really, or something else. It will not be really heating. The temperature will not increase, but energy will be infused into the oligomer mix, and the polymerization starts, right? So that is why there are ways, but I would not say directly that, trimming can be used there. Probably not trimming, but rather going through cause-effect chain analysis.
Okay, doctor. How can design for patentability be used to draft the claims?
To draft the claims, well, you see, just going from the back. So trimming, it is removing components. So the fewer components there are in the claim, and the more basic, if they described in a basic way, the less probable that people will trim them, right? So that's what, but it is kind of, those rules, of course we can explain them, from the point of view of trimming, from the point of view of substitution, that is more difficult to circumvent. So probably, that's another area to look into, because probably we can dig more out of that. But within the practice of people who draft claims, there are kind of these rules that were obtained through practice, not through some theories, but through practice. Those engineers or patent professionals who draft patents, they know that the fewer patents you have in your claim, the stronger the patent is. Going into the details basically makes the patent more vulnerable, right? Again, generalizing also, makes the patent stronger, but there is another boundary there. Generalizing too much will make patent the application rejected, because very general idea is not patentable. By the way, that is why in Japan there is a very well-known technique. They filed two patents two applications for the same idea, with the interval of 1 day. First, they file a patent application that is very, very generic, very few components, and very, very generic. You look at that application and you think, who can in its mind draft such an application? Because definitely it will be rejected, but it is done on purpose, because what if not? There are patent examiners of different qualifications. There are not experienced ones. Miracles happen. But a day after, they file another patent application about the same thing, but the claim specifies very, very, very small thing, very narrow, protects very, very small portion. That patent application should pass noiselessly, because the protection field is very small. Why do they do that? If they get lucky and the patent examiner is stupid or not experienced, and if the patent examiner grants them the patent for that very generic thing, good, they're lucky. If the patent examiner is normal and start kicking out that application, saying that is not patentable, narrow down, this is fraught with prosecution history estoppel issues, because you can in the long run narrow down and lose all the rights to use doctrinal equivalence, so your patent will not protect much. So they abandon that generic, just general patent, and they just focus on pushing this very narrow one that is very easy actually to push through. It will pass, but they will enjoy, you know, pretty broad protection through the doctrine of equivalence, because the patent protects not only what is literally written there, but also the whole field of equivalent solutions. And there is another area, but that field of equivalent solutions can be pretty broad. That's why easy patenting of very narrow claim, you know, can give you a substantial protection through the doctrine of equivalence. You know?
Yeah. Thank you, Doctor.
Yeah.
The next question is, can we patent the idea and concept of product or process?
Yeah, we can patent a device, and we can patent a method. Very often, one patent actually combines. It is like a method of something and a device for exercising this method. Yeah. So yeah, you can patent.
Okay.
Patenting processes or methods, you know, for some companies, they are not preferred, and they don't do it. For example, in fast developing industries like in microelectronics, they never patent, usually they never patent methods, technologies, processes. Why? Because again, to understand that the patent is infringed, the patent on the process, you need to penetrate to the factory of the competitor and to see that they are doing something differently. To see the infringement of a device, it's very easy. You buy the device and you do reverse engineering, and you disassemble it, and you see that the patent is infringed. To prove that the process, the patent on a process is infringed, is much more difficult. And besides, if the technology, if the area of engineering is evolving very fast, it does not make sense to patent, because it takes 3 or 4 years to get a patent sometimes. By that time, the technology would evolve beyond recognition. That is why many microelectronics companies, for example, Intel, they prefer not to patent. They keep many things a trade secret, because after several years, the patent will not hold any value, will not make any sense. That's why they do not patent the methods or processes. Right.
Thank you, Doctor. Can we apply TRIZ for improving quality of product or process, or maybe in synchronization with techniques like Lean or Six Sigma, etc.?
Well, sure, of course, of course. That's a natural fit, because as I told you, I gave you an example from BAT about identifying the best range of parameters under which they run that infusion process. That's a project for Six Sigma, you know, to determine that most optimal range of parameters. You know, Six Sigma project can do that, and they can patent that solution. Sure.
Great. Okay. Does the trend of engineering system evolution define or justify design for patentability?
Of course, of course. We did not talk about strengthening much today, but one big part of it is developing dependent claims. And the trends of engineering system evolution are marvelous for developing dependent claims for a patent. And dependent claims serve many purposes, because you know, if you think about it, for an onlooker, you know, they usually ask the question, why do we need to have all these dependent claims? Many patents have like 100 dependent claims. First of all, it takes time to develop, and then it costs money, you know, to file those, to maintain those. So why do we need that? If we have a very strong, very powerful independent claim, why do I need those plethora of dependent claims? If the independent claim will cover everything anyways. Well, the usual answer from patent professionals is, who knows, maybe you think your independent claim is strong, but when you file, the patent examiner starts kind of ringing you. In that case, you can take some features, some things from dependent claims to strengthen your independent one. So it's a resource. That is true. But also there is a patent strategy that is called Picket-Fence Strategy. if someone has a very strong patent, a core competence patent that cannot be circumvented, like we cannot circumvent a patent on the very first patent on laser. So one of the ways how to deal with that, you develop improvement solution. Again, commercially feasible and very important, improvement solution. So you file patents on the improvements. You cannot use them because those patents are still under the umbrella of a more generic competitive patent, but you still do that because at some point, if you protect those commercial applications or significant improvements, you start limiting the owner of that core technology. You can surround him or his patent or her patent, whatever, with a fence of your improvement techniques, right? That's, what the strategy is. But if you are filing yourself, right? And if you are filing something important, believe me, very soon your strong patent will be surrounded by the fence of others who want to kind of strangle you and induce you to cross licensing on whatever. That's why at the time of application, of filing, why should I give this benefit to the competitors? Maybe I will actually build this protective fence of improvement solutions myself. I will surround my strong patent with the fence of improvement solutions of my own, right? And trends are very good tools for that. That's why trends could be used for patent strengthening pretty much. And also for patent, it's not circumvention, but it's dealing with competitive patents, basically surrounding the strong patent of competitors with improvements of your own. And that's where trends can help. Of course, it costs money because for quite some time, you pay money for patenting these things, but you cannot use them until the owner of the core technology understands the value of your improvements and would agree to negotiate the cross-licensing.
Thank you, doctor. And we got last 5 minutes, and I'll just take the last 2 questions. And people who are missing out with these question answer sessions, and I have more questions, you may please note down Dr. Sergei's email address, which is flashed on your screen.
Yeah.
And you may just mail him, and he'll be happy to answer those. So I'll just take last 2 questions. The first question is, can we use TRIZ or DFMA for better solutions?
TRIZ or DFMA?
DFMA for better solutioning or problem solving, basically, I can say.
So TRIZ and what is the second?
Or DFMA. DFMA. DFMA.
Design for? What is?
Design
assembly.
Pardon me?
Yeah, for assembly. Yeah,
manufacturing
DFA or
okay.
Yeah, by manufacture. Yeah, because usually it's like DFM or DFA. Manufacturability or. So can we use TRIZ for that? Sure. Yeah. There are the tools of DFA of design for assembly. I listened to a couple of courses and manufacturability. Yeah, people who practice that. There are some embedded TRIZ there, into this. They are not as sophisticated as within TRIZ projects, with all this ranking and all these very, very many details of the methodology. But, quite generalized concepts, they are used in design for manufacturability and design for assembly.
Thank you, doctor. And the last question, which I would like to take, it's not a technical question, but many people have asked for this. Where can we get the design for patentability certifications in India? And will this presentation of yours be shared with the participants?
Yeah, the presentation, the PowerPoint, it can be shared. I can send it to you. Mm-hmm. Right. I will maybe I will think about it. Yeah. First of all, I will share. I will think maybe I will remove a couple of slides, but in general, yes. Okay. I can send it to you. Yeah.
And the second part of the question is, where do we get the Dfp certification in India?
Call me. Call me. In India, it's still kind of, again, what was, that very well. What was done in India, it was primarily the old TRIZ for IP strategies. And that was primarily circumvention by trimming. That's what has been done. In a way, there's kind of, relatively new stuff. Well, it has not been deployed too much in India. In China, yes, a lot. In Europe, yes, but in India, we did not have, full-blown design for patentability training. But another thing, right now we are in the middle of writing a book. Probably like 60% of the book is written because universities do not want to take it really seriously if there is no training book that can support the university course. That's why right now we are just trying to complete the book. Mm-hmm.
Great. And do you also offer any distant learning education on design for patentability?
What education? Distant?
Distant education, yeah, remote education.
Right now, it's only remote. For the last 6 months, I do only remote. so I don't do face-to-face education for the last 6 months. I don't think it will happen very soon. I mean, face-to-face education. When it happens, I'm pretty sure that remote education will stay. Yeah.
Right. And we're actually running out of time. It's only 2 minutes, about 7 o'clock, and we'll be just winding up for the day for the session. And in case anybody has further more questions, you can please note down Dr. Sergei's email address, and he will be happy to answer those. And in case you will also want any to reach out to Dr. Sergei, you may please reach out to him directly, or you can just write a mail to me, and I can connect you to Dr. Sergei. And once again, Dr. Sergei, thank you very much on behalf of all the participants, and not forgetting the support partners who supported in this session.
Thank you very much.
Center for Innovation, ASM International, Co-Create, M-Legal, ASM Audio Shikshan, and also Global Innovators Entrepreneurs Network. So without their support, we couldn't get the participations which we got. We were 300 plus in this particular session today. Wow. So thank you, Dr. Sergei, once again. And we'll meet soon. Take care.
Thank you.
And
Thank you so much.
Have a good day ahead. Bye-bye.
You too. Bye-bye.